25. Okay, so you've got implicit differentiation again, and notice their product. Okay, you get them. So u is 2x, v is y. So du dx is 2, dv dx will be, well, y becomes 1 times then dy dx. Product rule then, crisscross, so v du dx 2y plus then u dv dx 2x dy dx. Work this out then, y squared becomes 2y dy dx, plus then that becomes 4x, okay, bring the 2 down, plus then this 2y plus 2x dy dx, minus 9, well that just becomes 0, equals then 0. So you get then, factorize the dy dx, okay, take all the other stuff over the other side. Dy dx then will be, now to get what we want then, on the top I would take out minus 2, it's a factor. On the bottom take out 2. 2's will cancel, so you end up with what they want there. Okay, exactly what we're looking for there. Okay, part B then, this is interesting. It says determine the coordinates on C, so the tangents to C at these points are parallel to the y-axis. Okay, so determine the coordinates on C, so it's coordinates, so that means there's more than one set of coordinates, so such that the tangents to C at these points are parallel to the y-axis. Now basically, diagrammatically, if you think of a curve, just a quick sketch of it there, right? The curve might be going something like this, and then the tangent at this particular point would be vertical. That's what it's saying, because it's parallel to the y-axis. Okay, so we'd need that particular point, and it's saying there's 2 points, so you never know. It could be something like that. The curve could be, so there'd be another point. Okay, it doesn't matter what the curve looks like. It's just get the idea across here that at these particular points, the tangent is parallel to the y-axis. Okay, so what we can say is, if tangents are parallel to y-axis, think about what dy dx is. Think about what the gradient is of this line. Okay, well, it's not equal to 0. Okay, it was equal to 0 in the last question because it was parallel to the x-axis we discussed, so it's flat, but here it's vertical. So gradient isn't 0. Think of gradient as the slope, yeah? It's the slope of this line. Well, the slope, really, here you can't get a bigger slope than this, can you? Okay, because you're literally dropping on you. So actually, with a vertical line, okay, dy dx is so big, actually, it goes to infinity, okay? So that's what's happening there. The gradient is infinite, okay, because the slope, well, it's just vertical, isn't it? Okay, so that's what happens when you get a vertical line. The gradient is infinite. So if it's infinite, if we take that gradient there, that we worked out in part 1, okay, that tends to infinity. What is actually happening here is that this will go to 0, okay? Remember, you can't divide by 0. If you divide by 0 on your calculator, you get a math error, okay? So when this goes to infinity, this will equal 0. Okay, that's what happens there. So if you think back to the last question, if you look at the last question where it says dy dx was 0, when dy dx is 0 and it's flat, then the top was equal to 0, wasn't it? Okay, but when the tangent is vertical, parallel to the y-axis, the bottom part here is equal to 0. Okay, so you always put the bottom part equal to 0 when dy dx goes to infinity. So the bottom part is equal to 0. Then you could say y is equal to minus x. Okay, so you take the x over the other side, so you've got this. There's your expression there. Okay, and then all you've got to do then is substitute that into your curve. Okay, so remind ourselves of the curve. Okay, there's the curve there in the question. So just substitute in y. So y is minus x, so put that in this time. Okay, so that's x squared. This is 2x squared, that's 2x squared, that's minus 9, equals 0. Okay, so we get 5x squared minus 9 equals 0. So then 5x squared would equal 9, so x squared then would equal 9 over 5. So x would equal plus or minus square root of this. So square root of 9 is 3 at square root of 5, so it's quite nasty there, isn't it? So we've got the x values there. Of course then to get the y values, well we know y is equal to minus x, okay? So when x is equal to root 3 over 5, y will equal to minus root 3 over 5. And when x is equal to minus 3 over root 5, y would equal to plus 3 over root 5, because y is equal to minus of x. So there's your coordinates there. Okay, put it in coordinate form, and you're done.